All right, hello everyone. Welcome back to Data Programming 1. Today we're going to be talking about variables and expressions, and we're getting into doing some programming, so the course is starting to get a little bit exciting. As we do that, I'm going to be doing a lot of examples and a lot of programming exercises. Please try and follow along, pause the video if you need to. Writing Python code really builds your muscle memory, and just typing it is another way to learn things. So by following along and actually doing all of the examples while I'm doing them, it helps you learn better. I want to start out with just a little bit of review. Last time we were talking about different operators, and I've got a list of a bunch of the operators right here, but I've mixed up the order. What I want you guys to do is think a little bit about precedence. Some of the operators, if they're merged into the same statement, will be acted on first. So Python's going to take any expression and try and simplify it. Simplify it down into a number or a text or a Boolean value like true or false. So what I'd like you guys to do is just take a look at this list and figure out which one of these is going to be the highest precedence. Which one goes first? All right, if you've made up your mind, I'm going to go ahead and give you the answer. And we'll just go through this list one at a time, highest to lowest. And I'll pause between each of them. You can give it some thought and make a commitment. Write it down maybe. Okay, the very first one is exponentiation. That's the double star operator, not the shift 6 caret. Just so you, and I'm going to go ahead and make that mistake a couple times during the course just because I can't remember, and MATLAB does it differently. All right, so next up, what do you think is next? If you said the signs, these are the unary signs that make a number either positive or negative, then you are correct. All right, keep going. What's next? That's right, multiplication and division. And this includes the regular multiplication, which is the star, not the x. Sort of regular division, just like your calculator does, that'll give you a floating point number with a decimal place. The integer division, that will round down for you. And it's always going to be rounding down. If you get negative 1.5, it's going to round down to -2. And then the modulo operator, or the way we would say it is mod, this is going to give you the remainder. All right. What comes next, guys? Addition and subtraction. That's right. These top four here are the math operators, otherwise known as arithmetic operators. Those are always going to come first. So we do all of the math first before we do any. What comes next? Comparison. All right, quick reminder, the double equals is this equal to? Is the left side equal to the right side? The single equals we'll use for assignment. That's coming up today and later on in the lecture. But the double equal is used for comparison. The exclamation point equal is used for not equal to. Then we have less than or equal, greater than, and greater than or equal to. Okay, and these are all of the comparison operators. So they all fit in one box here. They all have exactly the same precedence. All right, now we only have 3 left. These are the Boolean operators. And they go in this order. First up, not. So not is just going to take anything that's true and make it false, or anything that's false and make it true. Following that, we have and. So and is a lot like multiplication. For an and statement to be true, both the left-hand side and the right-hand side need to be true. So when we simplify one of these, if the left-hand side and the right-hand side are both true, the composite statement will be true. Otherwise, it's false. And finally, hopefully that one you guys got, is the or statement. And this is going to be a Boolean statement where the left-hand side or the right-hand side, if either of them are true or both of them are true, then it'll be true. If they're both false, only then will this statement be false. All right, let's take a look at a quick example here. Let me pull up PowerShell and get into Python. Remember, that's Python on Windows and Python 3 on a Mac. If I have a statement like 10 minus 2 / 3, let's take a look at this one. I'm not going to push enter just yet, but what I'd like you guys to do is answer the question, how many operators do we have here? And how many operands? All right, pause the video, give this some thought, and then when you're ready, make a commitment. Write down your answer so that you've made an informed decision, your best guess. All right, hopefully I've stalled long enough. So the answer is we have 3 operands. 10, 2, and 3 are all operands. And we also have 3 operators. We have the subtraction, we have the negation, so that's going to make this -2, and we have integer division, so 3 operands. I'll jump back over to my PowerPoint slides. So when we look at a statement like this, here's my 3 operands. The very first thing that's going to happen when we evaluate this is we'll take the -2 here and actually make this 2 into a negative number. And then we're going to use integer division. If I take -2 and divide it by 3, that would be 2/3, -2/3, and we're going to round that down to -1. Okay, following that, we're going to do subtraction. It's going to be 10 minus -1, which is going to be 11. And just to show you guys that I'm not lying, I'm going to go back over here, give focus to PowerShell, and execute that statement. All right, what happens if we rewrite this a little bit? Let's add some parentheses so that the division actually comes before that negation. What's going to happen now? Make a prediction about what you think the answer is going to be, and then push play again. All right, so what's going to happen here is I'll take 2, divide, so that's integer division by 3. So it goes in 0 times with a remainder of 2, so that's going to be a 0. And then when I take 10, subtract, then at -0, the sign will come next. I'll have -0, which is still just 0. And then 10 subtract 0 is going to be just 10. All right, let's do one more of these. In PowerShell, I can just highlight, right-click, and then right-click again to copy and paste. What I want to do is answer the question now, what happens if I do the division last? Got an extra character in there. Okay, so 10 minus -2 / 3, integer division 3. So what's going to happen here is 10 subtract -2. The -2 will be first. Then we do the subtraction. We'll get 12. And 12 divided by 3 is going to be 4, remainder 0. And indeed, we do get 4. All right, let's take a look at one more example. Here I have 1 + 1 = 2, or 3 raised to the power of 1, 4, 5, 6, 7, 8. Looks like 10 million greater than 2 raised to the power of 20 million. All right, go ahead, give that some thought. And pause the video. When you've got an answer, what does this evaluate to? Let me know. So the answer here is true, of course. All I need to do is look at the 1 + 1 = 2. That part is true. And the moment I know that a statement is true, then I don't even care what the rest of this is. For an OR statement, if either side is true, then the whole statement is true. And Python's good at this. It's only going to take a look at the left-hand side, and then if that's true, it's done. It skips the rest of this. If it's false, then it does need to go over here and evaluate the right-hand side. So let's take a look at this one more time. Let me copy this. We'll paste it. And just run this again. Watch how fast this happens. Okay, awesome. Now I'm going to change it again. I'm going to ask if 1 + 2 = 2. So that will make the first part of the OR statement, the left-hand side, false. And it will have to evaluate the right-hand side. So check this out. Just watch how long this takes. All right, that was about 13 seconds. No video editing magic, I just let it run. And I've got a pretty decent computer here. It's a few years old, but not bad. All right, so Python knew instantly that it didn't need to do this horrendous computation. When it skips doing the second half of a Boolean statement, either because an AND statement has the first half false or an OR statement has the first half equal to true, that's known as short-circuiting. In fact, we can do some really interesting things here. Suppose I take 1 divided by 0. That's going to give me a division by 0 error. But if I do something like 1 + 1, is that equal to 2? Or 1 divided by 0 equals something big. Oops, I got a typo there. I need my double equals. There we go. it's going to know instantly that's true. It did not give me the zero division error. It never even needed to try and divide by 0. So just to be really complete when I'm talking about short-circuiting, here I have all the different possibilities for an OR statement. True or true is going to be true. True or false is going to be true. False or true will be true. And false or false will be false. So take a look at these first two statements. They both begin with true. It doesn't matter what this is. So I can say that true or whatever x is going to be true. I also know that if either of these are false, then Python has to go back and evaluate this second one. So if I say false or x, note that true is true, those two match. False is false, those two match. So I can say false or x is x. All right, now check this out. This is fascinating. So if I go back and say true or x, it doesn't even need to evaluate x. If I say false, or let's give it something valid, like hi, it's going to know that it doesn't need to, it's going to skip this first part. It knows it needs to evaluate hi. And instead of getting this to return a number or, a Boolean value, it's just going to return whatever this is. And this can be extremely deceptive for new programmers, and even myself, I make this mistake occasionally. Python's really powerful, but this is one of those things that tends to trick it up. What if I'm trying to find out if 3 plus 4 is equal to 6 or 7? I just can't remember. 3 plus 4 equals 6 or 7. That makes perfect sense in English, but this is actually going to evaluate to 7. Here, let me just push go. Whoops. Check that out. I forgot the double equals again. That's, whoops, twice in one lecture. All right. I hope you guys are counting my mistakes. You can put in comments how many mistakes I make at the end and just make a fun game of it. There we go, 7. And here's what's going on. 3 plus 4 is not equal to 6. So this is false. The first half evaluates to false. And when I have an OR statement, then I need to evaluate the second half. And this is going to return 7, not true. I expect this statement to be true. So if I want to do this, what I really need to write is 3 plus 4 equals 6. Or, and then I need a complete expression that's going to be true or false. 3 plus 4 equals 7. So I can write it like that. And now it should tell me this is true. All right, just move on. I want to talk a little bit more about expressions and operators and operands. All of these things here are expressions. Probably the best way to think about an expression is something that Python can simplify down to a number or text or Boolean value, true or false. So 5 plus 5 could definitely be simplified. This expression can be simplified. All we have to do is the math. This one, I've got a relational operator here, so this is going to be true or false when I evaluate it. And even this complicated one with the modulus and the assignments, it's got an or in there, should evaluate to true or false at the end. So each of these operands, everything in here, all these numbers are examples of literals. A literal is just a value that's fixed, can't be changed, the way that a variable can be changed. So here, a variable is just going to be a place in memory that I've named that stores some information, some data. So x plus y is an example of using variables. X could hold the number 5, y could hold the number 6, and I could use that to evaluate an expression. But because I'm using variables, those are not fixed. At a later point, I could change the value of x and execute this again, and this expression would then give me a different answer. So all of these things in red on this page, in my examples here, are examples of variables. These are the exact same expressions I had over here. So here I had 5 plus 5, now I've got x plus y. I'm just using variables to hold or to represent those numbers. Here I have diameter and pi. Here I had my diameter, it's 8, and pi, 3.14. All right? Hope that makes sense. All right, so pop quiz. All right, I'm just joking. No points on this one. Take a look at this list and identify which one of these are literals, and we'll go ahead and circle those, and the rest of them are going to be variables. All right, so take a moment, identify which is the first item in this list that is a literal. All right, if you picked 0, then you're correct. 0 is a number, it's a fixed value, it can't be used to represent something else. All right, look down the list, identify the next literal. And if you picked true, you're correct. So check out this one. 0 here is the word 0, not actually the number. So Python's going to use the number to represent, the literal value, the number 0. This is going to be a variable name. In fact, you can use this. I've actually used it in code that I've written, usually to represent 0. Num1 is a great example of a variable name. It's not something that we would say is a number or text or a Boolean value. So true with the capital T is the next literal. So the two Boolean values that are available are true or false, both capitalized. That's another mistake I'm going to make a lot because my other class is in C++ and they use lowercase. Forgive me when I make that mistake. I'm not even sure you guys should count that one if you're tallying up how many mistakes I make. All right, one more here in this list. If you guessed goodbye, then you're correct. Goodbye is a string that's in quotation marks. Those quotation marks are going to make this a literal. We've got some text here. Hello also looks kind of like text, but it doesn't have the quotation marks. So that means this is going to be a variable. And we can use full words as variables. All right, so let's talk a little bit about assignment. Let's go back here. These are those same expressions I had before. After I evaluate them, it would be great if I could store that data. Right now, if I use these in immediate mode or in Jupyter Notebook, it's just going to print out the value of whatever the expression yields to the screen. If I'm using this in a script, it's going to go ahead, it's going to take the time to compute it, and then it says, okay, I guess you didn't want me to save it or print it or anything, so it's going to go away. And Python will not remember it. So to do a variable assignment, all we're going to do is, first I'm going to make some space on my slide so that I have room to put in the equals. And this is the single equals. We'll be using the double equals like this one right here for comparison. The single equals is assignment. And then we'll put in the variable names. And I can use anything I want for variable names within with some rules. I can use complete words. In fact, I think the name rules are on the next slide, but I'll get there in a second. A great way to think about this is the name of the variable, and then in your mind read gets. Okay, so total gets whatever this expression evaluates to. So Python is going to do the right-hand side first. It's always going to simplify these. It's going to bring this down to a number or some text or Boolean, and then just store the result of this computation in total. So total gets, if x is 5 and y is 5, then it's going to store 10 in total. All right, I skipped way ahead because I wanted to talk about a little bit about the name rules first. Then we'll come back to the demo. All right, so the variable naming rules in Python are actually really complicated. Python 3, the designer's goal was to make this as friendly as possible to non-English programmers. So there are lots of characters that are allowed. So what I want to do is give you guys some guidelines. If you want the complete rules, got the website link right there. You can go and check it out. But what I want to do is give you guys some guidelines about things that will always work. So if you're working with an English keyboard, if you use only the letters A through Z, uppercase, lowercase are both fine, numbers and underscores, you'll be fine. Limit yourself to those. There are a lot of special characters that are also allowed. Do not start variable names with a number. That's not going to work. And don't use any Python keywords like true or false with them capitalized. And is another one. We're not going to cover any of the naming rules in other languages. So in my demonstrations, these are the only variable names I will use. I will follow these as rules. All right, so let's take a look at some of these. Here I've got a list of variables that are good. CS220 is perfect. Capitalize, also good. I'm allowed to use underscores. I can even start my variable names with underscores. A lot of times these are used for special things. And we'll talk about conventions probably in the next course, not in this class. All right, and here's some examples of things that are bad. So let's just give a look at these. So 220 class. This is bad because it's using violating rule number 2. It's starting with a number. Yep, there we go, rule number 2. And is a reserved keyword. In fact, it's in my example right here of things that are bad. Don't use that. Pi 3.14, the decimal point right there, the dot, period, that's the word I was looking for, is not permitted. Letters, numbers, underscores. So that's going to violate rule number 1. And the exclamation mark also not allowed will also violate rule number 1. there's a lot of things in Python that are not keywords. They're not reserved, but they're used for specific things. Like the type of a number that's an integer is called an int. Type of a text is called a string, str. Some built-in functions like length, len, are also things that Python will let us use as variable names, but that's going to replace the built-in things with the new variables, and then that'll lead to errors elsewhere. So please never name your variables after types or these not keyword but things that are built in. It's going to lead to problems. Alright, so I just jumped back over to interactive mode with Python, and I just want to go through some examples of variable assignment. So I can just say x equals 5, and it's not going to print anything out. The assignment doesn't do that. So if I want to do that in immediate mode or interactive mode, I can just type x and it'll give me the value. So there I have assigned 5, the number 5, and stored it in memory location called x. I do the same thing. Y is equal to 3, so there's a second one. I can print out y. Alright, I can also do something like z is equal to x plus y, and that'll store whatever 5 plus 3 is in z. Let's find out what it is. Alright, indeed 8, so that looks correct to me. Alright, some other things we can do. So because interactive mode here or immediate mode is going to let me just type the name of the variable, if I'm in a script or if I'm in Jupyter Notebook and it's not the final statement, I'm actually going to need to print things out. I can use, x. I can print out variables using just the print statement. Print x is going to give me the value of x is 5. I can go ahead and change the value of x. I can say x is now equal to 10. And now if I print x, it should print out 10 because I've changed it. So the 5 is now gone. If I print out z, however, so remember z was x plus y. That was 5 plus 3. I stored an 8 in there. It did not go back up and update z. Z got the number 8, it's storing 8. It's not remembering that it's x plus y and recomputing it every time. It's just evaluating the expression and then giving it the number at that time. From then on, it's frozen. Okay, so the right-hand side can also be an expression. I'm just going to do something simple, 3 plus 4. So it'll evaluate the expression and then store that. That means that I can also use, print that out, 7. Just to show you guys, I'm actually pretty good at math, but I make mistakes when I'm doing stuff like recording or have an audience. A lot of mistakes. All right, because they evaluate the right-hand side first and then store whatever that simplifies to in the left-hand side, I can do stuff like this. X equals x plus 1. So it's going to go, when it evaluates this, it's going to go to x, find out that it's 7, add 1 to it. This right-hand side is now 8, and store that in x. So, and then print out x, we see that it's 8. This sort of structure is extremely common where I'm updating a variable with something. So Python actually gives me a shortcut to do anything like x equals x plus something, or x equals x times something, or x equals x subtract something. And this is going to be the plus equals operator. It has the same precedence as the assignment operator. So I can do x plus equals, and then I can add 3 more to it. So this is going to be exactly the same thing as though I had typed x equals x plus 3. I recognize that it's only saving me 1 character of typing. But if I'm using longer variable names, this can be actually a lot more efficient. So this is going to say x equals x plus 3, or 8 plus 3 is equal to, in this case, 11. We'll store that in x and print that out again, and we get 11. All right, at this point, I'm back over on our webpage. We are down here on Friday. I'm actually recording this early. Check this out. It's Thursday. That says PM, not AM. I'm very excited about this. All right. And eventually our code will be, or the video will be right here. The reading, please read Downey chapter 2 while I've got this open to remind you guys. We'll have the code from today's lecture available, as well as the slides. But what I want to do is introduce you guys to a brand new tool that's just awesome. I really wish I had this when I was learning programming. It's under Tools. This is Python Tutor. So I'm just going to click this. It'll open a new window for me. All right, and this lets me type Python code in this window and then visualize the execution. This is great but I really love the live programming mode because it shows me what's going on step by step. So I just clicked that live programming mode. Let me make this big enough that it shows up well if you're watching on a mobile device, hopefully. All right, so I'm just going to type some Python code. I'm going to say x equals 3, y equals 4, print x plus y. And as I go through, it's going to go through and do all of this stuff. I can say, let me make it a little smaller so that I can actually see the controls. So I'm going to go back to the first step. So I clicked first. This red arrow tells me the line that's about to execute. It's the next line that will be executed. So if I click next, it's going to say, go grab some space. Here we go. Name it x. Put the value 3 in it. For right now, ignore this global frame. Ignore the blue box. That stuff isn't important yet. Next thing I'm going to do, the green arrow is the step that just executed, which will be important when we start skipping over code with conditionals like we did in lecture 2. But the red one's going to be the next line to execute. So I'm going to click next. It's going to reserve some space, call it y, and stick the value 4 in there. All right. Now, as you guys go through, as you're using Python Tutor, it's a really great learning tool. What I want you guys to do is, it's really tempting to just click next, 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 last, and see if it worked. But what I'd like you guys to do is, before you click next, make a prediction about what you think is going to happen, and then see if that really comes to pass. Python Tutor is a great learning tool, but all of our homework is going to be done in Jupyter Notebook. That does not provide you with this immediate feedback, letting you know what's going on, or a picture of what's happening in the memory model that Python is using. So let's do that. We're about to print x plus y. So we're going to take the value 3, add the value 4, we get 7, and it should stick that in the print output box right up here. So let's do that. There we go, 7. All right, I want to do a couple other little things while I've got Python Tutor open. I'm going to print x plus capital Y and just see what happens. And we'll go to last. It gives me an error here. I've got the screen too big. Let me shrink this down a little bit. Sorry about you guys on mobile devices. It says the name Y is not defined. So as it went through this, it went to X, grabbed the 3, went to capital Y. It looked at my list of named variables and found that there was no Y. And this is known as a name error. I make these all the time. I misspell things, particularly if I'm on a live programming or recording. I'll probably leave a bunch of them. I won't edit them out just so you guys can see the things I've done wrong. All right, let's do another one. Print. Let's do x raised to the y power. And I'm going to go ahead and delete this line. Actually, x plus capital Y. I'm going to leave this, but I'm going to put in a pound sign in the beginning. This is going to make this line a comment. So comments are code that is not executed. It's completely ignored by Python. In fact, I can write comments at the end of the line, and everything from the pound sign on is ignored. All right, Python. There we go. Excuse me. So if I execute this statement right here, so we'll do that one next. Looks like it already did it. It's giving me something weird. It's giving me 7. What's up with that? Remember, this is not the exponentiation operator. This is not what I intended. I wanted to do x raised to the power y. I'm going to go ahead and we'll comment that out. And then, if you remember, the actual exponentiation is the double multiplication side, the double star. And that's giving me something that looks a lot better. 3 raised to the 4th power. Let's see, 3 times 3 is 9, times 3 is 27, times 3, 81. That looks good to me. All right, so I want to go back now and talk about some of these mistakes that I made. This one is known as a semantic bug. This one is a syntax bug. I feel like syntax error feels better when I write it. I'm going to go with that. All right, so let me jump back over to my slides, and we'll start talking about some of these different kinds of errors. So syntax errors are like grammatical errors. They're things that never make sense in any context. Python won't even run these statements. So here's a good example, 5 equals x. It's trying to say, okay, go grab whatever is in the memory location x. In my example, I think I had a 3 in there, and store that in the number 5. Well, 5 is a literal. It's not the name of a variable, so I can't store it. So 5 can't get x. Remember, we can use the word gets to try and make these statements make sense. Here's maybe a better example in English. Maybe it's not better, I don't know. But just some word soup. Cat, dog, the, of, chase, any. That just doesn't make sense when those words are in that order. All right, the next kind of category of error is something that's grammatically correct, like this sentence is false. All right, think about that for a second. Grammatically correct. If we go to an English professor, they would say that sentence is fine. If we go to a philosopher, they would say, don't make my head explode. I can't think about that stuff. It's a semantic error. No, I used the wrong word. A runtime error. Runtime error. A runtime error is something that's not actually, that we don't recognize that it's incorrect until we try and do it, or until we think about it. We can look at the grammar and say it's fine, but only when we try and do it is there a problem. Runtime errors, we've seen a bunch already. The divide by zero, syntax wise, as far as like the rules of grammar, I can put a number here, I can put a divide, I can put another number, so the grammar is fine, but it's impossible to divide by zero. So this is going to give us the zero division error. That's a runtime error. All right. And finally, here's another example. 1 week is 10 days long. We go to a grammar expert, they're going to say, sure, I got a subject, a verb, I've got nouns here, 10 days long. It's all good, but it's not actually right. If you go and ask someone who's completed first grade, they're going to tell you there are 7 days in a week, not 10. So this one is known as a semantic error. It runs without an error, but you don't get the answer you expect. Like here's another one. Square area is equal to square side times 2. We're trying to compute the area of a square. So I take the length of the side, I square it, but in this case I haven't squared it, I multiplied it by 2. To fix that, I would need another star. All right. I want to ask you guys the question. Which one of these 3 kinds of errors is the most bad? Personally, didn't even move on. Personally, I really dislike semantic errors. Those are the most difficult to track down. Syntax errors. Python tells you. It straight up tells you there's a problem with that line right here. And you go, oh, there it is. Runtime errors. They are also brilliant. The computer crashes. It gives you a zero division error and tells you which line has the problem. Those are a joy to fix. And you're going to spend a ton of time debugging. Probably more time debugging than you actually spend programming. Semantic errors. The program runs just fine and the answer is wrong. Those are hard. You've got to look at every single line. And throughout the course, we'll talk about some strategies for trying to identify what's going wrong, where a semantic error is coming from. All right, guys, I'm back. I just took a break because I had a meeting, then I worked out. Thursday is Zoom night. Then we had some dinner, and I'm pretty sure I was going to do this demo next. Anyway, I'm going to do this demo next anyway. Let me just tell you a little about it. All we're going to do is take these 4 variables that have the values 3, 4, 5, and 6 assigned to them and write a little code that sums up the odd values. In this case, it'll be 3 and 5. We should get 8 as the answer. Let me hop over to Python Tutor and we'll get started. First off, I'm just going to copy that problem. So we've got A is equal to 3, B equals 4, C equals 5, D equals 6. And when we run this, we should see A, B, C, D over here in the box. Don't worry about what global frame means. We'll talk about that later. But I've got the variable name and the value. All right. So I've got this. Eventually, I'm going to want to print out the answer. So print something. All right. And the answer in this case is 3 plus 5. All right. Now, this isn't the best way to do it. There, the answer is 8 right there. This is not the best way to do it. I've hard-coded this. I didn't use any of my variables. Suppose the next person comes along and says, well, let's make A 2. It's still going to print 8, no matter what. Even in fact, if A is still odd, let's make it 5. Now 5 plus 5 should be 10. It's still printing 8. It never really took advantage of those variables. So let's go back and let's fix that. Change this to A plus C. Those are the 2 odd numbers. That's great. We're still getting the correct answer. It's 8. If we change this to another odd number, oh, there we go. It's 10. Perfect. This is also not exactly what we need. It's still not, what if B happens to be 5? It never updates. It doesn't take into account the fact that B is now odd and we need to include A, B, and C. We should be getting 15. So how can we make this better? What we really want is some code that's going to work for all inputs. I need a way to figure out how to make sure that if it's odd, we get it added into the sum. If it's not odd, we want to leave it out. All right, so beginning in like another week, we'll talk about conditionals. That's a really easy way, it's elegant, easy to read kind of way to make this decision. We can just ask if A is odd, then we'll add it. If B is odd, we'll add it. But for now, we haven't talked about conditionals yet. We're going to have to do a little mathematical trickery. So here's what I want to talk about. Let's just, for a moment, make this a simpler problem. I'm going to comment out A, B, C, and D, and we'll just work with A for right now. And when we, it's frequently a good idea to work with the smallest possible data set that we can use to solve the problem. All right, so here's the idea. What I'm going to do is use the modulus function, A mod 2, in fact. And when I print that out, A right now is an odd number. When I divide by 2 and look at the remainder, if the remainder is 1, then this number must have been odd. Let's try some other ones. If it's 4 divided by 2, then the remainder, by the way, it's printed out right here in this output box. I can make this a little bigger while we're doing this. There we go. 0. If it's 3, the remainder is 1. That's an odd number. So here's the idea. Here's what we're going to do. Is we're going to take that either 0 if it's even, 1 if it's odd, and we're just going to multiply. Let's do this. A equals A times, and then that, we need a 0 or 1 right here, so we're going to do A mod 2, just like that. So this piece right here will either be 0 if it's even, or 1 if it's odd. Okay, and when you do that, I can use this reassignment. So we've got 3 times 1 in this case, so A should still be 3. Let me take this out and just print out A. There we go, we got 3. If we put in an even number, put in 4, this piece right here, A mod 2, 4 mod 2 is going to be 0. Anything multiplied by 0 is going to be 0. And so we reassign it. And also remember that the entire right-hand side is evaluated first, even though I'm using an A, and then it's reassigned to this A over here. And we can take a look at this and watch it happen. Let me go here. We'll go back to first, and we'll just step through this. First thing that happens is A is equal to 4. It makes this. Now it's going to use the 4 in this expression and reassign A to be 0. There we go. Made that change. And last, we will print it out. All right, so here's the idea. This is what we're going to do for all 4 of these. So I can just copy, paste, paste, paste. I got to make some changes here. We need a B, C, and D. A B, C, D, B, C, D. And now we can add them together. Plus B, plus C, plus D. And let's just make sure this works. Do I have any mistakes in here? Yes, I do. So look at this. Right here, I have a name error of some kind. Keyword can't be an expression. That's because I no longer have a B when I run this. I commented out the line where B is equal to 5. So it gets down to this line right here and says I need B times something. And B in this, wait, it's using the parentheses first. So B mod 2. There is no B, it can't find it. And so this is what's giving us the error. In fact, if I put that comment back, we should see that there's now an error from the C line. Let's go back to first, run the code. B is not defined. It's right there. What am I doing wrong? Keyword can't be an expression. All right, guys, I'm going to think about this. Let's see what I'm doing wrong. Let me pause the recording. All right, I found it. This is a valuable lesson right here. So I'm going to keep this mistake in there and I'm trying to figure it out. But here it is. Keyword can't be an expression. Line 11. I never finished reading this. So check it out. Right here, A plus B plus C equals D. That needs to be a plus. And then it totally works. So in this case, I've run the code 4, 5, 5, 6. It should be adding the 5 and 5 together. When we do these little math manipulations, at the end, the even numbers should be changed to zeros. The odd numbers should be retained. Let's just check this with some simpler things. We'll put a 1 in right there. 0, 0, 0. We should get 1. If they're all 0, it should be 0. If we put in a 1 and a 1, it should be 2. Let's move that around. 1 and 1. And then let's do the real problem. All this seems to be working. So we'll do 3, 4, 5, 6. Should get 8. All right. So I hope one of the things I want you guys to learn when you watch me do this and fumble through things is that I'm doing things step by step, and I'm checking my work after every single step. I made the problem simpler to talk about just the A line, but at every single step, I had this print here. I wrote it before I wrote anything else, and I was just printing out some stuff. But every single time I looked at my code and made a change, I printed it out, and I checked what's going on in the output box. All right. My son has karate right now. I'm going to pause the recording again. He's going to go work out, and I'll be back for 2 more demos maybe. When I edit the video, we'll see how much time there is and put in however many fit. All right, be right back. All right, guys, we're back from karate. I want to do maybe a couple more of these. If you're one of those people who are really frustrated when the lecture goes past 50 minutes, I'm just going to do like 3 more. When you get to the point where we hit 50 minutes, go ahead, stop, ignore the rest of this. For those of you guys who want to see all the demonstrations and maybe learn as much as possible, feel free to keep listening. All right, so here's what we're doing. I'm going to start with $1,000. We're going to have the interest be 7%, and we're going to wait 30 years and just see how much money we have at the end of 30 years of accumulating interest at 7%. All right, so I'm going to hop over to Python Tutor and start taking a look at this problem. So first up, we have starting money. Let's just call that start, and that's $1,000. So we'll just create some variables. We'll give them values. Let's see here. We also had interest, and that was 7%. And then we had a duration. Let's just call that years. And we had 30 years. Okay, the formula for compound interest is, basically it's the amount we start with, the principal, times the interest rate raised to the power of how many years we have. So let's just break this down a little bit more. Let's we'll print out the answer. Let's call this money. And then we'll compute the amount of money we have. Let's say money equals 1,000. We'll just start with that. And we'll run this. Just make sure that we have 1,000 printed up here in the box. All right, cool. So here's all of my data. Start, interest, years. All 3 of those variables are there with their values. Perfect. And then I just assign money a fake value of 1,000. We actually started out with start for the amount of money. So let's go ahead and put that in. Just make sure that we do have 1,000 here. All right. Then, when we accumulate interest, I'm going to multiply by, let's see, it's a percent, so that means I need 1.07 if there's only 1 year. So that looks great. But we really have 30 years. So let's go ahead and raise that to the 30th power. All right, there's the formula for compound interest. I've got a couple of issues right here. First up, what if I change the interest rate? What if we actually make 8? That doesn't change anything because I hard-coded it right here. So that's not a great plan. So let's go ahead and change that back to 7. Here's what we're going to do instead. I'm going to go ahead, and I need this to be 1.07 because we keep all of our original money, that's the 1, and we get an extra 7%. So that's really the same as saying 1 plus 7 divided by 100. That's my interest rate. This 1 because I keep all the money that I had, and this is how much it grows. That's 7%. So let's actually redo this. Let's call it interest. We'll just reuse that variable name, and we need that 7 to be the original number here. So when it computes this, it's going to see I've got a variable named interest. It's going to go grab that 7, put the 7 in here, and it's going to convert this to, well, actually, maybe I don't want to use interest. Let's call it multiplier. Yeah, I like that better. That way my interest will stay at 7. We're not going to change it. And we have a new variable multiplier. So I'm just going to pop that down into my equation right here. All right, looking good. I still have one more thing hard-coded, and that's years right here. Instead of 30, what I really want to use is the number of years. That way, suppose I only have 0 years. That should give me 1,000. All right, if we have 1 year, that should be like $70 more. Is that about right? 1,070? Yeah, so we have 2 years. It should be about 1,140, but we also earn interest on that extra $70, so a little bit more than 1,140. So that's all looking good. Let's go ahead and put that 30 in. That'll be the final answer. And I'm just going to not worry about the rest of those digits. What's a floating point number? We'll talk about how to get rid of those later in the course and turn this into something that actually looks like money. Good enough for right now. All right, I want to do this example too. I really like this one. So this is just, we've got two people playing a game, Alice and Bob. Alice has 8 points, Alice has 10 points, Bob has 8 points. What we want to do is make a bar graph with these vertical bars. So we said 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 for Alice, and 8 for Bob. So we're going to start with this version, and then we'll eventually make it look like that version. All right, so let me go ahead, pop over back to Python Tutor, and we'll walk through this example. So just as a reminder, I'm going to put 2 comments at the top. We want Alice, colon, space, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we want Bob, colon, space, 1, 2, 3, 4, 5, 6, 7, 8. So that's what we're going for. That's our first target. All right, so first, let's make up some variables. Let's see, I could say that we could have Alice score equals 10, Bob score equals 8, and then we could just print these out. Let's see, print Alice colon 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and print Bob 1, 2, 3, 4, 5, 6, 7, 8. All right, let's see what this looks like. Do I have any mistakes? Yes, I do. I forgot the quote. I forgot another quote right here. And now, there we go. Exactly like we wanted. It's perfect, right? So I want to ask the question now, how can I make this better? What if we want to use this same system, but Bob is actually playing against Carl? So I want to be able to change their names. So let's go ahead and upgrade with that. So let's see, what should we call these people? How about player 1 equals Alice. Player 2 equals Bob. Yeah, I kind of like that. And now we can get rid of this part down here. We have player 1. And we'll just use string concatenation to add in that colon, the space, and the bars. Yeah, it looks pretty good. All right, let's do the same thing for Bob. We'll go to Bob. We'll have player 2. I need a plus right there. There we go. Looks the same. But now, if I wanted to, I can change out Bob for a Carl, and it's still going to look good. All right. Leave it for Bob right now. Next thing I want to do is, what if Alice actually gets 12 points? That doesn't change my bars. I've hard-coded these. So instead what I want to do is upgrade this a little bit. I want to be able to actually use this Alice score variable where it can change in my print statement right here. So let's go ahead and change this a little bit. I'm going to add a quote, and then let's just put in 1 bar. All right, do you guys remember during the previous lecture when we were laughing maniacally? I was able to take a string of text and just multiply it by a number to repeat it. Ha 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 ha. Okay, so now I'm going to do the same thing. I'm just going to put in 1 bar here, and I'm going to multiply it by 10. And voila, it's giving me 10 things. Now I've hard-coded this. This is not desirable because it's still not going to add 12 bars if Alice scores 12 points and I change it up above. Instead, what I want is, you know what? Let's not call this Alice score. Let's sort of make it match this one. Let's call it player 1 score. And then we'll have player 1 score right here. How's that look? There, it's working again. Let's make this 25 and see if it gets bigger. Check that out. I'm looking right up here in the output box. That's looking good. All right, put it back to 10. It should shrink back to 10 bars. Perfect. All right, so let's do the same thing for player 2. Right there, we'll just go ahead, plop that down like that. I've got to change my 1s to 2s. 1 right there, 1 right there. And then instead of Bob's score, I don't have a player 2 score yet. We need to make one of those. There we go, it's looking good. So now I can change the names of my players. I can change their scores. Let's just make sure that works. Yep, that looks good. Now, this would look even better if the bar graph right here for both of their scores lined up a little better. All right, so I'm going to make that upgrade right now. To do that, we need to know how many letters are in their names because we need to add some spaces. An easy way to do that would be to just hard code this like that. And now they're going to line up. There's an issue here. I've got my colon though. Hold on a second. Did the example have a colon? Yeah, the example had a colon. So take me back over here. So we could put the colon in right here instead. But that would be hard coding. What I want to do is show you guys a better way to do this. And for that, I'm going to print out, let's just call this length equals, the function I'm going to use, ing, length equals, the function that's built into Python that I'm going to use is length. It's just like print in that it's going to compute something, and it just takes a string, player1. All right, and then we'll print this out. print. Yeah, if you guys check out the clock, it got late on me. It's almost 10. So this is telling me that 5 letters in Alice, A-L-I-C-E. Cool. I can do the same thing with player 2. It should tell me that I've got 3 letters in the name Bob right there. Perfect. Now, I'm going to make an assumption here. I'm going to say, let's assume that the longest player name we will ever see is 7. Longest name equals 7. Okay, let's go ahead with that. And then what I want to do is add some spaces. So, and the number of spaces I need will be 7, the longest name, take away the length of each player name. And we'll go ahead and put the spaces in that way. All right, I made a change of my mind. I want to put the colon in right here. We'll have Alice with the colon, Bob with the colon. Except I'm not going to do it like that. I kind of like my player names to not have that right there when I stick the name in. So I'm just going to do this. Player 1 equal plus equals, we'll give the colon like that. Then player 2 plus equals the colon. And now when I look up here, I should have 2 colons. So I'm just going to get rid of this. I don't need to print that out anymore. And right here. So that should give me the same thing I had before. Now, what I want to do is add spaces to my player 1 and player 2 names so that they take up 7 spots. So player 1 will add spaces, and the number of spaces I need is longest name, take away the length of player 1. So in this case, I've got 6 characters because I added the colon right there. 5 there, 1 makes 6, 7. Oops. Whoops. Slow down, Mike. Stop making mistakes. I need to just move that line up. And that's going to add, so player 1 plus equals not the longest name. What I really want is space times longest name. I got to add text. There we go. We'll do the same thing for Bob. So let me walk through this. So Bob is named player 1. It's player 1 right now has Bob and a colon. And now I'm just going to add spaces to that. And the number of spaces I'm going to add is, in this case, 7. Take away the length of Bob's name with the colon. So that's 4. So I'm going to have 7 take away 4 is 3. I'm going to add that many spaces to Bob's name. And that's going to shove all of this stuff over. And now I can see easily that Alice is kicking his butt 10-8. Well, she's winning by 2. That's kind of hard to count. I'd have to stare at that. All right. So that's doing exactly what we wanted. I'm printing out some extra stuff right here. I'm going to go ahead and take that out. I no longer need it. So now I have a complete, awesome, gorgeous looking program that does exactly what I wanted. All right, final example. This one's pretty straightforward. What I want to do is check to see if a number is between 0 and 100. If it is, then I want to print out you may continue, true. If not, you may continue, false. All right, so let's head over to Python Tutor and do it there. There we go. I've got a brand new Python Tutor setup running. So first thing, we need a number. Let's call it X. And let's give it a value, something that's definitely going to be in the zone between 0 and 100. And now I need to know if this number is valid. So what we're going to do is a little bit of math. So if X is greater than 0 and X is less than 100, then we want to keep it. we want to print, this is going to be the true. So basically we can take this Boolean expression right here and assign it to a variable. Frequently, if we're testing to see if something is valid, using valid as a variable name makes a lot of sense. All right, hopefully this makes sense. I've got two Boolean statements here. On this side, I've got a relational operator that's testing if it's greater than 0, and then if less than 100, then we know it's going to be good. That's the value we want to keep. So when that's true, we want to print out, we need to quote, you may continue, colon, space, and then we just want to add valid. All right, this is going to give me an error right now because print does not type bool. We need to turn this into a string. All right, this is coming up in a future lecture, so this is just a preview of the future. To turn something into a string, it's a function called stir to turn it into a string. And now I can just give it an integer, a float, whatever I need to turn into a string. And when I see up here, you may continue is indeed true. All right, let's test a couple of other numbers just to make sure this is really working. So between 0 and 100 is valid. So let's stick in a million and see if that's valid. No, you may continue false, not valid. Let's try exactly 100. It says it's got to be between 0 and 100. So I'm taking that to mean greater than 0. 0 is not included. So this is, and less than 100. So 100 should not be included either. So not like 99 should be good though. Let's see, 99.9 should also be good. Let's see if that works. Also true. And 0 should be out. False, but 0.1 should be in. Okay, that looks good. 0, false. 0.1. Where am I typing? I lose focus. 0.1, true. All right, so this is going to do it for me today. I'm going to, for you guys who are watching the live stream, we'll have some live Q&A. If you're not, if you have any questions, you can post them on Piazza or come visit our office hours. Have a great day, everyone.